In the last video, I told you that we were going to go on to bigger and better things, and those bigger and better things are going to be called ethers in this section. So just like with the halogens, we're going to have to learn how to recognize an ether and how to name an ether in two different ways. A IUPAC way and a common way. All right, so just to review, an ether group is ROR, and R represents random. Random what? A random group that contains particularly carbon. So if you want to refer to this as a COC, then that is okay with me as well. But keep in mind that the carbon to the left and the carbon to the right, it could just be one little old measly carbon. That's perfectly fine for an ether. It doesn't have to be big and substantial and nasty looking. Or it can be carbon that brings a lot of buddies to the ride. All right, so I can put a little squiggly out here to let you know there's more stuff. Well, that's what the R group represents. The R group is anything random that carbon wants to bring into the picture. So anything is okay for an ether like this. We're going to keep these simple. We're going to keep these very clean, at least in the very beginning. It might not look like that, but I promise you that they are going to be cleaner structures as far as the ether is concerned. Two different ways to name an ether. We have a common name, and we also have an IUPAC name. All right, so the way that we treat these, for the common names, these are a little bit easier in the world of ethers. People really gravitate toward the common names here, and I know that what you're saying, you're probably screaming at this point, saying, well, I thought you told me that we're trying to get away from common names. And yeah, it's true. But ethers, the common names make so much more sense, and we can visually see these structures better if we have the common names over the IUPAC names, that people really do prefer the common names in the world of ethers. But we still do try to get away from common names. It's a little bit harder in this field because ethers are better understood with their common names instead of their IUPAC names, and you will quickly see this as we start doing some examples. All right, so the common names, how do we do it? Well, we name the group to the left, and then we name the group to the right, and then we add on the word ether at the end of the name. That's it, guys. That's all we got to do. Okay, IUPAC I'm going to leave off for now. We're going to go back to IUPAC after we do some common nomenclature examples first. Then we'll go back to IUPAC and we'll see how those change. But common names, name the group to the left, name the group to the right, and then add the word ether on. Now, when I say left and right, I also want you to keep in mind alphabetizing is very important here as well. That never goes away. So what I do is I name the group to the left, I name the group to the right, and then when I write down the actual common name for this structure, I make sure that I still put those in alphabetical order. Okay, that's still a requirement. But at least I've named the groups already and I know where they need to go. All right, so let's take a look at some examples of some ethers, and we'll talk about how to name these, just the common nomenclature, and that's it. All right, so CH3, O, CH2, CH3. Let's start here first. All right, so I named the group to the left. That one carbon is going to be called methyl. This is something that's never went away. It's a rule that's never changed. Over to the right-hand side, it's a two-carbon chain. This is going to be called ethyl. All right, so I've got a methyl group and I have an ethyl group. So what I need to do when I write down the common names, I write them down in alphabetical order. So ethyl comes before methyl, and then I add the word ether onto the end of that structure. So ethyl methyl ether is the name of that molecule. All right, next, CH3, CH2O, CH2, CH3. All right, so we got to name this a common way. If I name the group to the left, this is called ethyl or ethyl. If I go over to the right-hand side, this is called ethyl. So I would write them down in alphabetical order. Ethyl, ethyl, ether. And you're close. No cookie, though. You're close. The reason is because these two groups are the same group, and anytime we saw that in the IUPAC system so far, we actually just used the prefix here to make it a little bit better. You know, I don't want to say ethyl, ethyl, ether. I mean, I could, but think about how repetitive that is. Ethyl, ethyl, ether. All right, so what I'll do is I'll put the word di in front. and we'll call it diethyl ether. All right, it's a little bit cleaner. It's a little bit less work. I don't have to write down as many letters when I write it down. I save myself some time. So use that prefix when you can, diethyl ether. But here's the story with ethers. If you do not see the word di here, and let's say that someone just wrote down ethyl ether, then it's understood to be duplicated. That's just the way the ethers work. Now, I still would prefer you to do this. All right, so on a test or on an assignment, I still would prefer you to put that prefix on there, diethyl ether. But if you do not put the word di in front, then we make the assumption, that's the key word, an assumption that the ethyl groups or ethyl groups are the same on both sides. So there is a di there if only one thing is listed. That is just an assumption, again, that we make throughout this process. All right, so diethyl ether is preferred. But if you just see the word ethyl ether, then know that that really does stand for an ethyl group on the left and an ethyl group on the right. Okay? All right, next one. Let's go a little bit more complicated, shall we? CH3, CH, CH3, oxygen, and then we've got CH3 up here, CH3 there, and a CH3 down below. Okay, so I'm going to name the group to the left, and this group to the left, I see that L group right there, right? So this L group is an iso group, and there's 3 in total, so this is going to be called an isopropyl. And then over here to the right-hand side, this carbon is attached to 3 others. So this is a tertiary carbon. The common name for this thing is a tert, and there's 4 carbons in total, so it's going to be called a tert-butyl. All right, so I've got a tert-butyl and an isopropyl. Keep in mind that I told you that the terts and the sex really do not get included in the alphabetizing, so this is really a B, not a T. So that means that that is written first. So a tert-butyl, and then an isopropyl, and then the word ether that follows that. All right, so there is the common name for that particular ether, tert-butyl isopropyl ether. Okay, next, let's do another example. All right, so I'm going to clear this out, and we'll do CH3, CH. We'll have a CH3 that points down here below. Then we'll do a CH2, a CH2, an oxygen, and then maybe a ring. And I have to give this as a common name. All right, so I'll name the group over here to the left. That's a big fat group, right? I mean, look at all these carbons and hydrogens. So I've got to come up with a common way to name this. And if I look here, this is an iso group on the end, right? There's my L shape. So I know that this is an iso something. Well, if I count the total number of carbons, 1, 2, 3, 4, 5, this is going to be called an isopentyl. All right, over here to the right-hand side, this is a 6-membered ring that's directly connected to that oxygen. So this is going to be called a cyclohexyl group. And now I need to put all of those together. C comes, of course, before the I or the P does. So this is going to be called a cyclohexyl isopentyl ether. And there is the common name. All right, so here's the thing with these. Notice that these are getting bigger. They're getting much more bulkier. And there's going to be a point in time where we can't really give it a common name. Okay, and the reason is because we are limited to what these groups are actually going to be. And if I can't have a common name that represents like this iso group, or if I can't have a common name that represents something like the cyclohexyl group, and this is a more complicated type of structure, then a common name does not exist for that particular ether. All right, so just keep that in mind. That is why we do IUPAC nomenclature for ethers, because there's going to be a point where a common name cannot be a common name because the group is going to be too complicated in order for me to name it that way. All right, so we'll do one more common example. And here I get the CH3CH with the CH3 that points down, and we'll put an oxygen there again. And then I'll do something like a CH with a CH3, a CH2, and a CH3 here. Okay, so we got to name this a common way. So once again, I name the group to the left. I see that L formation that begins to happen. This is a 3-carbon system, and the oxygen's connected to the middle. So this is, once more, the iso group, and this is an isopropyl again, because there's 3 carbons in total. Now over here to the right-hand side, this is not really the L that happens here on the end, but this is 1 carbon shifted inward, right? It's still the L shape, but it's not happening at the end. If it did, it would have happened right here. That would be the iso unit, but it's not. It's going the next carbon in, next to the last one, right? So this is a secondary carbon. It's a butyl group. So that's a very good sign that this is going to be a sec something, and it's a sec butyl here. 4 carbons in total. That oxygen is connected to a secondary carbon, and there's only 1 type of secondary carbon here in order for me to make that decision, okay? So we're going to name this a common way. The secs do not get included in the alphabetizing, right? Just like the terts do not. So this really is a B that we start with. So sec-butyl, and then isopropyl, and then the word ether that happens toward the end. All right? Okay, so that's it with the common nomenclature system for ethers. Now, we also have another nomenclature system, and that nomenclature system is going to be the IUPAC, and they will treat this in a different way. So here are the rules for the IUPAC. Whenever we name ethers with IUPAC, and let's say that we don't have a common name for a group that sits over on the left or on the right, who knows? This structure is going to be a little bit different for me. How do we do this? All right, so what we do is that we, number 1, normal IUPAC rules, find the longest carbon chain, and we're going to name it just like we always have: butane, pentane, hexane, heptane, and so forth. All right. Number 2, we identify the number carbon of where the O is going to be attached to. Is it the 2nd carbon in? Is it the 3rd carbon in? Is it the 8th carbon in? This is very similar to what we've done in the IUPAC rules as well, very early on. There's no changes that have happened here yet at all. Next, then we name the OR group. We have to give this a name, and the way that we give it a name is that we name the number of carbons, and then we add on the word oxy at the end of that instead of the ending of YL. So for instance, if it's a propyl with an O on it, we're going to call it a propoxy. The prop means 3 carbons in total. The oxy represents the oxygen that is part of that ether group. All right, so what on earth does that even mean, right? Well, let's just go ahead and do an example, and you'll see what that means. All right, so we'll do CH3, CH. Oh, hold on. Let me erase that mess. We'll clean that up a little bit. CH3CH, and then we'll do CH2, CH3, and we'll do an oxygen with a CH3 group that's here. All right. So they want me to IUPAC name this, not common name it. All right. If we wanted to common name it, this would be like a methyl on one side and a sec-butyl on the other. And I could call it that, right? I could call it sec-butyl methyl ether. That would be the common name. But they want IUPAC here. So this is how I do IUPAC. Find the longest carbon chain. All right, so the longest carbon chain is going to be 1, 2, 3, 4, right there. 4 all the way across. There's my longest carbon chain. So this is going to be a butane here. All right, well, on carbon number 2, because that's going to give me the lowest number, on carbon number 2, I have this group here, and I need to name this group. All right, the way that I name this group is that I look at how many carbons that contains, and there is a methyl there. But I don't call it a methyl. What I do is I erase that YL, and I have to add on the word oxy because it includes the oxygen. Make sense? So this is going to be called a methoxy group. So on carbon number 2, there is a methoxy group, and this is called a 2-methoxybutane, and that is the IUPAC name for that particular ether. All right, so hopefully those rules make a little bit better sense now that we've done at least one example with them. All right, so let's take a look at another one. These are going to be a little bit bigger, a little bit beefier than some of the other molecules that we've dealt with, just because the purpose of the IUPAC is to tell me that this is a large, quite large ether that we can't really common name. All right, so here we go. Here's the structure of an ether, and we're going to have to come up with the IUPAC name for it. So rule number 1, find the longest continuous carbon chain. All right, well, I know it's not the 2 over here to the right. And if I go to the left, 1, 2, 3, and I go down to 4, I can beat that out. I go straight across, 1, 2, 3, 4, 5. So there's actually 5 carbons in a row. There we go. And that means that this ether is going to be a pentane for the IUPAC name. All right, now what do I do? Okay, well, I need to treat this group and I need to name it. That is regarded as a substituent. And that CH3 is called a methyl, just like always. And now I need to look at this group, and this group is going to be called a substituent group. It's hanging off of that longest chain, and this would typically be called ethyl, wouldn't it? However, because it's not really a true ethyl group, there's something else with it, there's an oxygen on it, this is called an ethoxy. So now I just need the numbers. Where do I number from? Do I go left to right or right to left? Well, hopefully you're going to tell me right to left, because that gives you the lowest group numbers in total. So here I have a 1 ethoxy because it's attached to that first carbon. And then on carbon 3, I have this methyl group. I put it in alphabetical order. Typically, that's what I'll always do, right? So this is a 1 ethoxy. And then on carbon 3, I have a methyl group, and the name of this is 1-ethoxy 3-methyl pentane. That is how we do this, folks. All right. So as you can see, the IUPAC names are a little bit bigger. I'm going to say they're a little bit more complicated. You can also tell why we prefer common names. They are simpler. They are easily to visualize. You can talk about ethers and know exactly what the structure is going to be like just by the common names that we are assigning. IUPACs, a little bit more complicated. We can do it. We can do it, right? We're good like that. We can do this. We're smart. But common names are much easier in the world of ethers. All right, so let's look at another example. CH3CH with a CH3 that points down and an O. And then I'll have a CH2, and then a CH2, and then a CH2, and then a CH2, and then an O. Yeah, another one. And then a CH, and then a CH3, and then here, let's point a CH3 that goes down. Oh my goodness. What on earth? This is an ether that I have to name. The answer is yeah, it's still an ether. But here I have 2 ethers. All right, I have an ROR to the left, and I have an ROR to the right. And that's okay. That's no big deal. I still use the rules of ethers the same way that I've always used them up to this point. Okay, don't let this throw you off. The difference is that there's 2 ethers now that I have to worry with, which is another reason that this does not have a common name. The structure is just too big, it's too bulky, there's too many things going on. A common name is not going to fit here. So I find the longest carbon chain first. All right, well, over here, 1, 2, 3. Okay, I can go bigger, I can go better. Over to the right-hand side, 1, 2, 3. I can do better than that. What I can do better with is right here, this carbon chain in the middle. There's my longest carbon chain. My longest carbon chain here is a 4-carbon chain, which means that this thing is a butane. All right? Now, I need to number this system. Do I number left to right or right to left? Honestly, folks, it doesn't even matter because you're going to get the same numbers no matter what. So I'm just going to do 1, 2, 3, and 4. Right? So on carbon number 1, I have this group that's attached. And on carbon number 4, I have this group that is attached. If I numbered from right to left, I'd get the same thing, 1 and 4. No difference. It's the same group. It's the same kind of type of group as far as an ether is concerned. There is no preference, rhyme, or reason on them. So 1 and 4. Now I need to name the group that's attached there. And good luck for me because they're the same group, right? It's a 3-carbon chain with an O. And here is a 3-carbon chain with an O. All right, well, how do we name this? Well, remember back in the day when we had these complicated branching groups off of substituents, and I said we can add a parentheses in, and then we treat this as a subchain, and we can go in and number them and name them a different way. We're not going to do that here. We could, but I told you that this was the exception where in the IUPAC names, it is okay to use things like isopropyl here, because that really does take care of the entire system as a whole group. All right, so this is an isopropyl, but actually it's not a YL. We changed that ending just like always, and it's a propoxy because of the oxygen that is there. This is the same grouping that's here as well. That's an isopropyl because I see that L structure, and there's 3 carbons, and that's attached to an O. So this is also an isopropoxy. All right, so up here in the name, this is going to be a 1,4 di, because there's 2 of them, isopropoxy butane. And I know it seems a little weird to have 2 I's back to back like this, but that is not weird in the language of organic chemistry. All right, organic chemistry is kind of a mind of its own, and di-isopropoxy is very acceptable. We keep those 2 I's side by side, and we do not get rid of them. All right, so 1,4 di-isopropoxy butane is going to be the name of that particular ether. All right. So let's do some more examples while we're on a roll. We might as well, right? So here's a question, and it says, what is each ether's systematic name? All right, so I want you to keep in mind that systematic name basically means the IUPAC name. That is what we're after here. All right, so number 1, I find the longest carbon chain. There's 2, so this is going to be ethane. And then on carbon number 1, I have this OCH3 group that's attached. That's how we refer to the IUPAC name. So that is a methyl, but in this case, it's going to be a methoxy. So this is a methoxy, sorry, methoxy, methoxyethane, or a 1-methoxyethane. All right. Here in number 2, common name, this would be diethyl ether, wasn't it? We already did that example, but this one wants the systematic name, the IUPAC name. So longest carbon chain here is going to be the ethane again, so I start there. And then on carbon number 1, I've got this O with the remaining carbons, and I need to name that. So this normally would be ethyl, but now this is going to be an ethoxy, because that oxygen is with the ethyl group. So ETHF and then OXY, ethoxy. And I can put a 1 here in front if I need to. I don't have to. It's understood to be a 1 if nothing is written. All right, number 3, longest carbon chain here. 1, 2, 3, 4, 5, 6, 7, 8. It goes all the way across. So this is going to be an octane. All right, so that octane here is going to be numbered, and I need to number it closest to the end with the OCH3 group. If I start left, that's a 1, 2, 3, 4, 5. If I start right-handed, that's a 1, 2, 3, 4. So this is going to be a 4 something, because that gives me my lowest group number. And this is a meth and an oxy. So this is a methoxy octane, 4-methoxy octane. All right, number 4. Here I find the longest carbon chain. 1, 2, 3 on the left, and that's kind of where it stops. Over on the right-hand side, 1, 2, 3, and down for 4, or 1, 2, 3, and across for 4. Well, because they're the same, doesn't really matter. I just shoot straight across. Keep it simple. There you go. So this is a 4-carbon system. That 4-carbon system is going to be called a butane. All right? All right, now with that butane, well, here is my main chain. And here on carbon 1, I have this huge big group with the O. And then on carbon 3, I have this methyl group that's also hanging off that I need to include in the name. All right, well, this is methyl. And what do we call this over here? This is an isopropoxy. So isoprop group and the oxygen for oxy. Isopropoxy group. So this is a 1 isopropoxy, right? And then after that is a 3 methyl, and then after that is the word butane. All right, so that is the IUPAC name for that particular structure. 1 isopropoxy, almost looks like poopoxy, don't it? It probably does smell like poopoxy. And then 3 methyl butane. All right, number 5, they give me a skeletal structure just to try to confuse me. However, I try to find the longest carbon chain. Here I've got 1 carbon, 2 carbon, 3 carbons. And then here I've got 1 carbon, 2 carbon, 3 carbon, 4 carbons. So 4 carbons are going to be my longest chain here. So this is going to be a butane again. And then off of the first carbon, I have this group that I need to name. All right, so this is a 3 carbon, which is a prop. And then I have an oxygen attached to that, so it's a propoxy. So propoxy, poopoxy, there you go again. All right, so I can put a 1 there in front if I want to. I don't have to, it's understood to be there, but 1 propoxy butane is going to be the IUPAC name for that structure. And then finally, number 6. Number 6, yet again, is a longest carbon chain. All right, so 1, 2, 3 on the left. And then over here, you might do 1, 2, 3, 4, 5. If you do that, that's wrong. And the reason is because that chain's longer. You can go 6. It's the longest continuous carbon chain. So 1, 2, 3, 4, 5, and 6. That means this is at spot number 2. All right. So 6 carbons. This is a hexane. On carbon number 2, I have this oxygen-containing group. Well, there's 3 of them. It makes an L, so there is my isoprop again, and this is an isopropoxy. So on carbon number 2, I have an isopropoxy, and then hexane follows that. So 2 isopropoxy hexane. Part B says, do all of the ethers have common names? No, they don't. I can go through and I can give you the common names of the ones that do have common names, though. Number 1, we can name this a common way. We name the group to the left and we name the group to the right. So this is a methyl and this is an ethyl. We've already done that one in a previous example, right? So this is going to be called an ethyl methyl ether. Carbon number 2, example 2. Here we have a 2-carbon system on the left and a 2-carbon system on the right. We can call this diethyl ether. Number 3 is pretty complicated, right? I can call this a methyl group, but what on earth do I call this? I mean, there's no common name for that. That's not an iso unit. Okay, you might look at this and say, well, what about a sec? That's a secondary carbon. No, secondary carbons are really only used for butyl groups most of the time. Because look, this is a secondary carbon, but this is a secondary carbon, and that's a secondary carbon, and this is a secondary carbon, and that's a secondary carbon, and that's a secondary carbon, and depending on where it's attached, it could be any type of secondary carbon. So this one, it doesn't really have a common name because I can't name that huge, big, long chain in a common fashion. All right. Number 4, what do we call number 4? All right, well, over here to the left, this is an isopropyl group. All right, so 1, 2, 3, there's my isopropyl. This is also an iso unit, right? 1, 2, 3, it makes that L. So there is an iso unit that's going to be there, but it's an iso what? Well, 1, 2, 3, 4, 5 carbons in total. That's an isopentyl. So I have an isopropyl and I have an isopentyl. So alphabetical order is isopentyl, isopropyl, ether. Ding, ding, ding. There you go. That's good news. All right, number 5. This is a 3-carbon chain, which that's a prop, and this is a 4-carbon chain, which is a bute. All right, so if I had to name this a common way, this would be a butyl and a propyl and the word ether at the end. Number 6. Does that have a common name? And the answer is no, that does not either. The reason, this does have an isopropyl group here, all right? But the problem is, what on earth do we name this big long thing here? Again, that's a secondary carbon, but there's other secondary carbons in there that will switch positions, that will be something completely different. So this does not have a common name for that group. It's too big. So therefore, this one does not have a common name either. All right. And then we've answered C by doing that. C says, what are their common names? So we just did that, folks. All right, so there's the story with naming ethers. All right, so hopefully you feel a little bit more comfortable with this at this point. Again, practice makes perfect. You're going to start seeing these over and over and over. The only way to learn organic is if you see things over and over, and that's why I spend so much time on examples. If I just throw out 1 or 2 examples and call it a day and move on, and not take 30 minutes like I did and give you a handful of examples to go by, you would never learn it. You would be so confused by the time this is over. You would be like, where on earth do I even start? And that's the problem with organic at other institutions. They do not take the time to go over these example problems one by 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 one. Right? What they do is that they quickly slap something up on a board, they say this is how you do it, and they move on to the next group. And that's not the way I operate, that's not the way that I work. That's what I had the most problem with when I took organic, and I had to go back and I had to teach it to myself. Literally, I had to teach it to myself. And this was one of the things that I said I will not do. So example after example. I know that I sound like a repetitive record going over these types of things all the time, saying the same things over and over, but it's good for you. That's the way that we learn organic, and that's the way that we feel comfortable with organic. So in the next video, we'll move on with our next functional group. That next functional group is going to be alcohols. So we're going to talk about alcohols. We're going to revisit that functional group yet again, and then we're going to go through and learn how to name those structures as well.